Hi, today we are going to start with a new topic, that is how to integrate a polar coordinate. The double integration using the polar coordinate. That is, we have already studied about f of double integral over r, f of r theta dA over the region r in polar coordinate. How to integrate that and how to find the value of the limits using the polar coordinates. Okay, so how will you find out this? The procedure is first sketch the graph, sketch the region, right? Next is take the r limits of integration, find r limits of integration. First sketch the region and label the bounding curves. And the second one is r limits of integration. Imagine a ray L from the origin cutting through the R in the direction of increasing R. Mark the R values where L enters, and that is from origin through the region. Draw a line. Okay, starting from the origin, cutting through R in the direction of increasing R. Okay, and mark the values of R values where L enters and leaves R. Here L enters into the region, and from at this point this line leaves from the region. So find out this R value here and here, right? Theta limits of integration. Find the smallest and largest theta values at bound R. These are the theta limits of integration. Okay. Okay, here this is the integral f of r theta equal to r dr d theta, dx dy is converted into r dr d theta. Question: find the limits of integration for integrating f of r theta over the region R that lies inside the cardioid r equal to 1 plus cos theta and outside the circle r equal to 1. Okay, here the cardioid r equal to 1 plus cos theta and the circle r equal to 1. Okay, look at the region here. First of all, we have to look at the region. This is the cardioid. Okay, and this is a circle. This is a circle r equal to 1, and this is a cardioid r equal to 1 plus cos theta. Positive side happens, then the length increased portion will be on the right side. Okay, so this the region between, I think the region is in between. Yeah, okay, inside the cardioid and outside the circle. Outside the circle means this is, inside the cardioid means, so this is a part of moon like portion. Okay, this is actually our region. Next we have to evaluate the limits. Okay, in this r theta varies from where to where. This is this center into theta equal to minus pi by 2, and this center theta pi by 2. So theta varies from where to where? Minus pi by 2 to pi by 2. And this, for in order to find the values of r, draw a line starting from the origin and through the region draw the line. This enters into the region at this point, and this end determines by r equal to 1, and leaves region at this point, and this point determines the curve r equal to 1 plus cos theta. So r varies from 1 to 1 plus cos theta. This is the limits. Minus pi by 2 to pi by 2, r varies from 1 to 1 plus cos theta into f of r theta r dr d theta. This is the limits. Okay. Next is equation is find the area in a polar coordinate. Find area in a polar coordinate. The area of a closed and bounded region R in a polar coordinate plane is A equal to double integral r dr d theta. Double integral r dr d theta. Using these, we have to find the area. Using these, find the area enclosed by these. The question is find the area enclosed by the lemniscate r square equal to 4 cos 2 theta. First of all, you have to draw the lemniscate. This is the 8 shape model, that is a lemniscate. Okay, 2 is its width. This is cos 2 theta. For a lemniscate, this is always from 0 to pi by 4. In the first quadrant, it is always from 0 to pi by 4. It is already we have studied. So in order to find the total area, we need only to find the area in the first quadrant only. After that, we will multiply with a 4. Then we will get the total area, because this is symmetric with respect to, this is cosine and this is r square. So this is symmetric about both x and y axis. Okay. So in order to find the total area, we need only to find the area for the in the first quadrant. In the first quadrant, the theta varies from, for the lemniscate, the theta is always varies from 0 to pi by 4. Okay. And next we have to evaluate the values of r. R value. In order to draw, so in order to find the r value, what we have to do? In the case of the rectangular coordinate, Cartesian coordinate, we have seen that using the strip, we can calculate the limits. Here we are drawing a line starting from origin through the region R. Okay, so this is starting from 0, right? And 0 means at 0 it is a region starting point, and moving through this and leaves at this point. This center determines by the curve r equal to square root of 4 cos 2 theta, that is 2 root cos 2 theta. So this is 0 to pi by 4, 0 to root of 4 cos 2 theta. Okay, so after calculating this, we will get that this is equal to square by 2, this is equal to 4. So today we have studied about how to find out how to integrate in polar coordinate, how to calculate the coordinates theta and r in this through the region r, and what is the equation for the area in polar coordinate, and we have done a problem also. Okay, so do the problem in the exercise also, and if any doubt comes, please ask me and do the exercises, and I will give some homeworks also. Okay, thank you.